Okay, so good afternoon everyone. I will try to be as quick as possible because I see already people drinking beer and I cannot actually wait and I'm feeling jealous. Okay, so my name is Altaf and I'm a senior researcher at the Technical University of Berlin, and I'm working in the field of cellular security for, let's say, 10 years now. And 5G has been a quite interesting subject. I mean, although it's not even there, but it's quite interesting how we see like how at least mobile networks evolved over the last, let's say, 30 years. So in this talk, I'll be giving a perspective on like what people think about 5G networks and like what interesting findings that we discovered, let's say, during the COVID time, and then what to expect in terms of 5G security playground and what is exactly 5G about. So 5G is nothing but COVID. Well, it was thought like COVID. So some birds died and then it was basically 5G again. Then COVID came and then it was 5G again. So they burned some towers and then like, so it was a huge, I think it was bad luck of 5G because it was exactly timed with the release of COVID, which nobody expected. And so people thought that, okay, it's everything because of 5G. So nothing like that. And so basically 5G also is not something like what you think is just an upgrade of 4G, or like, let's say, you're basically doing your phone calls, your data transfers, and then maybe a bit more high-speed data transfers with 4G connection. And I guess like people get irritated when you see Edge on your phone. But 5G is not just a technology that was designed just to upgrade 4G. So it's basically a platform where all the providers, like you name the provider, like let it be cloud provider or network provider or any service provider. So it's a platform where like all these providers can actually come together so as to realize so many use cases that were previously not possible. For example, like automated cars. I mean, this is nothing new. Or like connected vehicles, this is nothing new. But this was the concept that came even before 2008 or 2007 or before 3G as well. But until now, like we don't have them in reality because there is no like the radio technology like that can actually take this forward or like to make it a reality. But I think 5G will be definitely a game changer for all the industries that you see here. Automotive, media, agriculture, manufacturing, like there are so many industries that are going to benefit from this. So maybe at the end of the talk, I will give you how these industries will actually benefit and then where exactly do they fit in the entire ecosystem. In numbers, for sure, it's like so many gigabytes and then like 10 years long life battery for low powered IoT devices. Then, well, of course, like when you have these many billions of devices connected, you should really take security as seriously, like even more seriously. So there was definitely like a lot of effort put into security, like to improve the standards from 4G to 5G. So I will also take you through that as well. But we have to agree to the fact that 5G was spreading less than COVID. So there are only like very few deployments in the whole world. And these are also like not the real 5G deployments that at least the industries that we're expecting before. So basically there are like two types of deployments. The first one on the top you see is currently what we have, which is called a non-standalone mode, where either 4G base stations or 5G base stations are used, and the backend is anyway a 4G core network. So basically, it's nothing but the radio has been improved, but the backend core network remains exactly like a 4G one. But moving to the actual 5G network, which is a standalone mode, it has a proper 5G tower, which is connected to a proper 5G core network. And there's a huge difference between the core network that you see in 4G and what is in 5G. It's not just a simple upgrade, but there's a huge architectural change. Like the entire protocols are actually being replaced, or it's completely a new protocol stack, let's say. Also, there are like several reasons why there was a bit of delay in terms of 5G deployments. I mean, there are also politics involved. I think if you're following the security news, you might have come across some companies and then like some countries don't really like some equipment from some places. And so it was a huge fuss. So there are now regulations from many countries that they don't actually accept certain equipment. So they do have to go through, either they completely ban it or they go through a heavy security check so that they can be integrated for, let's say, 5G network. Because 5G is not just, like I said, it's something used for communication between phones. It's for government, it's for agriculture, it's for, like, let's say, mission critical application. So I think there is, there are like planned trials for the release of 5G. So at least if you look here, I'm not sure like how accurate this is, but this is from some of the EU documents, like at least 2025, some countries can actually expect a proper standalone 5G mode network. I also took a bit, I'm interested in this kind of subject, so I took, okay, what is exactly EU saying about it? So there, like I said before, there are definitely politics involved, why 5G was a bit delayed. And I think testing, like having special testing standards for 5G was something very important. So I think many standardization bodies like 3GPP were working on developing that so that 5G equipment can be completely tested before it actually goes into the live production or like live systems. Before actually going into what 5G and what attacks look like in 5G, I would like to just give a short recap of what actually happened on 4G. And the attacks can happen like from different angles. I think some people are aware of SS7 or diameter attacks. So I'm not talking about that because it takes quite a lot of time to explain them. But at least the radio side, which is over the air interface. So there are typically devices called IMSI catchers, or you can also call them Stingrays, fake base stations. So basically they simulate a real network so that they can actually attract commercial phones nearby, or any kind of like phone that has 2G, 3G, 4G support. The goal here could be to track these phones, or even to completely deny them, service to them, disconnect them from the real network so that there are no incoming calls and probably outgoing calls either, and silently like drain the battery of these devices. So there are definitely these kind of IMSI catchers around, used by, let's say, lawful interception or even illegally by anyone to attack specific set of mobile phones. These are some type of attacks that actually happen over the air interface, and there are different types. For example, maybe passive, which just listens to the air interface and tries to intercept the voice traffic or even data traffic and try to decode them maybe in real time or even at a later phase. But there are active and semi-active ones that are slightly detectable because they do make some active transmission over the air, and I think that actually helps to detect that there is some kind of like a base station in the surrounding. If you ask me what exactly is the reason like why these IMSI catchers or why these fake base stations do prevail and what is their success strategy. So it's basically they exploit some of the protocol design that was, most of these mobile protocols, let's say, they date back to 1990s, like how they function or how their design is. They of course, like there is additional security layer like generation by generation, but when you look at the basic design of the protocols, they remain the same until 4G. For example, if you take device registration, which is the most important step, let's say when you switch on your phone or like remove the flight mode, that is the basic procedure that actually happens. Like let's say, assuming you have a SIM card in the phone, the device authenticates to the network, performs the security mode registration. So basically the entire control plane and the data plane setup is actually done, and only after this you see that the bars are active and you can actually make a phone call or make a data session. And I think none of our phones can actually tell that whether a phone call is being made in plain text or whether is it being in an encrypted conversation. I think like most of our phones like don't have this support. Unlike the browsers, which actually show you that if you have an unencrypted session, like they immediately remind you, or if there is an expiry of the certificate, they give you an intimation so that user can take some action with that. But this is something different with the phones, because phones in this game are basically slaves, and base station is the master, like that says something and the phone has to follow that, and then just, let's say the base station says don't use encryption, phone will straightforward just switch off the encryption, and the user is not aware of it and it's completely going in plain text. If you look back, let's say over last 5 to 6 years, there have been like many attacks on especially 4G networks. Well, of course, like 2G, if you compare with 4G, has less security. So obviously that it would be more vulnerable to more attacks. But looking at 4G even, there have been denial of service attacks, location tracking attacks, or even hijacking like the classic attack where the DNS can be hijacked and the complete traffic can be routed to a complete random web server. These are some of the essential attacks that are actually being considered or considered by the standard body so that they don't repeat in 5G. So there are security measures which came up. But for all these attacks, if you look compare from, let's say, 20 years ago, how the attack setup looked like 20 years ago and what is it today. From small boxes to open source software and open source hardware, it's quite possible to perform these attacks with ease. And I saw something like a drone setup, I don't know, in a random conference. So somebody was able to fly a drone and just run an IMSI catcher with that. So this makes a bit scary, and then how things actually evolved with respect to, let's say, how mobile networks evolved as well. So now, what actually 5G does in terms of fixing these kind of security issues? I think the first one they put a check to was this IMSI catcher problem, because IMSI is nothing but it's the identity of your SIM card, which is exposed over the air whenever you're making a phone call or whenever you're just connecting to the network. So basically, this is exposed in clear text over the air. So this actually, if a passive attacker is listening to this particular end interface, it actually confirms the presence of the SIM card in that vicinity, let's say maybe 200 meters or even less than that. So that itself is revealing some sort of a location. But the problem here is the attacker has to be in the radio range. It's not like a remote attack that you could do from some strange country, but yeah. So how they fixed is from here onwards, your SIM card will actually carry, let's say, a special identity, not an identity, but it actually carries a public key that belongs to the home operator. Let's say you're using Deutsche Telekom, so it would carry the public key that belongs to that particular operator, and then every time the mobile phone actually sends this to the network operator, it would actually encrypt this IMSI and then send it to the mobile operator. So this is one way how this was fixed, and you can call this new identity as either SUCI or SUCI, which is nothing but SUCI, which is a concealed identifier. But then you have the permanent identifier, which is nothing but the IMSI, which I just spoke about. So I think in every, let's say in every network, there are temporary identifiers just to hide some real identifiers. So same way, there is something called GUTI, which exists in 5G networks as well, or even 4G networks, where once you complete attach process with the network, there is a temporary identity which is being assigned by the network, and usually it should be random, completely random, random with a previous one, or random with when you compare with your neighbor. So it should be a completely random identifier. But at least what we observed in, let's say, in 4G was this wasn't really a random identifier, and there was some weird algorithm installed in the core networks. Well, you name how many core network providers are there, hardly 4 or 5. And basically all of them have this same algorithm that generates this weird random identifier, which is basically not random. And that actually provoked for so many kind of passive and active attacks in 4G. But now there are strict regulations in terms of not only implementing them, but also testing that your random identifier should be really random. This is quite late. This kind of feature actually came quite late into the architecture, let's say, because normally when the client connects to the server, it would obviously send its security algorithms that are supported. But here, what happens is a man in the middle can actually change. Let's say if he has the access over the air interface, he can be a man in the middle and then try to change what kind of encryption algorithms that the phone is sending to the network. And basically just change them, remove them, or just set them all to null. And now base station thinks that this phone do not support any kind of, let's say, security algorithm. So basically I have no other option other than going in plain text. So this actually was demonstrated in many base stations. And I think especially in Germany, there were a couple of cities where they were picked, and then they were attempted to connect with zero capability or zero encryption capability mobile phones. So that actually worked. And basically, if you say, let's say if you know an IMSI of any subscriber or a target subscriber, you can basically put it in a SIM card, just connect it to the network, and then tell that you don't support any algorithms. Basically, now you are impersonating that particular subscriber that you want to target and using all his data and like voice call sessions or everything. Another feature which also came up is an user plane integrity protection, which is quite common in internet-based networks, but this is not the case with in mobile networks. But what happens is like it's possible to modify, like I said, in the DNS hijacking attack, it's possible to modify the DNS traffic because some researchers were able to identify encrypted traffic inside encrypted LTE packets. They were able to identify the DNS packets and try to modify them. That actually made them to bring, I mean, they called it alter attack, and then they made now 5G specifications to also implement integrity protection for data plane traffic, or you could also call user plane. Then there is another interesting feature which we also brought in was UV capability transfer. So if you look at some point like this is a simple screenshot of like how the mobile phone sends its capabilities to the network. So just a simple protocol switch, like altering the protocol, the sequence will actually completely deny, let's say, mobile services for the mobile phone. As you see in 2019, we see that the capabilities are sent prior to the security mode command. So which makes a man in the middle to just completely nullify this, the capabilities and then perform the security mode command. So hereafter, like the network thinks that this phone has no voice calling capability and no data capability. So basically, you are being denied with any kind of service. But after this, I think like many base stations updated, and then they now start doing the security first and then ask the device to send its capability, which makes more sense, so that now an attacker, like unless he doesn't have the key, he cannot actually modify these capabilities. Just getting back. So if you look at all the security features that I actually spoke about now are actually not available in the 5G NSA mode. They are something that only show up in a 5G SA mode, and most of them are kind of optional features unless the operator or your phone manufacturers like really considers to implement them. They can implement it, but if not, if it's it could be optional to use as well. So basically, whatever 5G networks we have now until date, like let's say 2022 or even maybe the next 2-3 years, they would be based on the 5G NSA, and they won't carry any of these security capabilities that I just spoke about. So which makes all these mobile phones or the new mobile phones vulnerable to all the attacks that I showed you in the beginning that affect 4G networks, because the 5G and NSA networks are actually based on 4G code. And I think I just said it. Okay, so instead of talking like this, like I also made some experiments in 2021, like checking back, okay, what we actually reported in 2015, has it been fixed in 2021? Well, not everyone, but I think there was a bug bounty discussion going on before where they say that it takes quite a lot of time for the vendors to actually fix. I think that even after 6 years, we really see that some of the networks haven't actually fixed completely. As you see, like in 2015, the random identifiers are not really random at all, but at least in 2021, one operator completely changes them. Like as we see, like it's completely a different identifier. This actually prevents tracking of the mobile phones. And another operator, well, although not completely random, but okay-ish random, then there's another operator which we see that even after switching off on the phone for like over a period of 10 days, we still see that it's still the same identifier. So basically, if you find this identifier over the air, it means that that particular phone is actually in the same location. You could use this kind of techniques to track your boss. Let's say when your boss comes to the office and then when he's leaving, if you find this kind of identifier over there, it means that it belongs to this particular phone or a SIM card, let's say. Downgrading attacks, I think the classic way how all the commercial IMSI catchers or like the commercial base, commercial Stingrays operate, and then they do cost around 200K. So they do push the user to 2G or a 3G network, and then they operate all the attacking techniques. But I'm not going to go through all the attacking techniques, but I'm telling that it's possible to downgrade a phone from a proper 5G network to a lower generation, well, let's say 4G. And it's also possible to downgrade to a 3G or a 2G, but however, like it requires some radio sophistications. But I think like in the next 4 or 5 years, I would really expect to see that someone demonstrate a downgrade from a 5G to a 2G network. But it's a bit challenging, but I think it's possible. Like I said, we also looked into the integrity protection because this is a feature that actually provided for the 5G base station. So I started looking at some of the base stations or like 5G base stations that have this kind of capability. So we only see that there is a ciphering algorithm which is called NEA2. It's the internal code name, but we don't see any kind of integrity protection algorithm which is activated. So which again makes us to think that like, okay, there are security features, but I mean, of course, they're optional to use and they're not being used unless, let's say, some researcher actually puts them out that, okay, there is a problem here and some of the networks are actually not using them. But I think because of lack of travel, we couldn't actually check it in many places, but at least 3 to 4 countries where we actually tested that there is no integrity protection over this user plane. Some guidelines for operators in this particular regard is that, well, of course, I think it's important to randomize the temporary identifiers so that they can actually prevent the tracking attacks that happened in 4G networks. Let's see what kind of like attacks are possible on a standalone networks, which we don't really have now, but at least there is one research which actually talks about how we can actually track certain type of users that are using only, let's say, 5G mode. As I said, the IMSI, which is the SUCI or a SUCI, it consists of like this. So you have your mobile country code and you have a mobile network code, and following that you have an encrypted MSIN. So basically, if you look at this particular whole SUCI identifier, you can actually tell to which mobile operator it belongs to. So you can say that, okay, that this belongs to Vodafone or whether it belongs to a Deutsche Telekom network. So at least that helps to identify some specific users. Let's say you're tracking for a SIM card that is in a roaming scenario. Let's say you're tracking someone from Thailand. So obviously if you look at a SUCI over the air and that has this MCC MNC of a Thai operator, so this indicates that that particular SIM card from Thailand is actually in this particular location. So it still didn't really solve the problem, but the problem kind of like still persists. But I think like the impact of this is kind of, I won't say negligible, but less than what it was before. So rather than exposing a complete identifier, you just exposed only some, let's say, side channel information. So just want to repeat, like, so all these features, I think, of course, they're optional, but if some wrong configuration goes in, so it will actually bring back all kinds of 4G attacks that I have actually shown before. This is all about the networks. I think networks play a key role in actually implementing, or like I said, the base station is the master, so they have the main role to actually implement the security standards properly. Not only that, but there are like mobile phones, which also play a key role here, because as you see that there is 2G still, and some countries, or at least Germany, got rid of complete 3G networks. So there is 2G now, and then there is 4G NSA or like 5G NSA, and you also have you may have 5G SA networks in some years. So it's basically possible to downgrade to 2G, which because all of our phones support 2G, and it's quite easy for an attacker to just send a simple message to the phone, and thereafter like the phone is sitting on 2G. And all sorts of attacks are still possible then. But the problem here is like none of our phones do have the capability to actually select a specific network that we want. So let's say I just don't want to use any kind of 2G, 3G or 4G network. I just want my phone to stay in a 5G network, which completely is not possible for me because as a normal user, I cannot set it, or I can set it to the highest. I mean, the default mode is like either whichever network, like 5G, 2G, 3G, whichever mode. But there is only 2G only mode, which is, I mean, I would expect like there should be a 5G only mode so that So that, like, let's say if you are someone who is worried a lot about like security, so you could still use such a mode. But there is also a downside for it, because let's say you won't have a 5G network everywhere. So I think it's also like in terms of service wise, like, or like availability wise, you won't find 5G networks everywhere. So you have to go down to 2G or maybe use 4G at least. Sometimes it's also possible that there are situations like where you might pull the plug off. So something similar was done by Android in, I think like from Android 12 onwards. So where they actually have a feature called disable 2G. So you can particularly go into your phone and then just hit this button. So hereafter, like, your phone will never attempt to go on a 2G network. Well, this is, I think like it's completely voluntarily. So I don't think by default it comes in this mode. We checked a couple of phones, and I think like all of them have the same philosophy, where they only provide this kind of modes, but there is no necessary for 5G only mode, or at least if you look at iPhones as well, there is only 5G auto, but that doesn't mean that it's 5G only. Okay, so this is what is about, like what has happened until, or like at least when you see from the radio interface. So these are the kind of attacks that what you see until now. But now 5G, because I said it's not just a platform where you can use your mobile phones to communicate, but it's more a platform where different industries like collaborate and then try to communicate. So for that, you need different kinds of technology such as SDN, or even virtualization, or even cloud platforms, or you say it like there is basically everything in 5G, and there are plenty of securities, or like, let's say security keywords, buzzwords, like so many engaged in 5G. So for me, I particularly find three important things here, like three important securities, which is, one is air interface security, which I just spoke, but there is another type of air interface security which I will show you. Because whatever I showed was just what is happening between over the air, so that either you could use a passive device to sniff the air, or you could use an active base station to compromise a bunch of phones in the surrounding. Then there is something called network exposure capability. This is the point where mobile networks actually open up to outside world or to outside industries, through which they can actually connect. Then there is a service-based architecture, which I said 5G core network takes a completely different set of architecture, where it separates the control plane and data plane, so that the network functions could be virtualized, because previously all these core network entities were coming from a specific vendor. The software comes from the vendor, the hardware comes from the vendor. So it's basically like a hardware vendor lock situation. So you don't have the software and hardware from that vendor, you're basically screwed. So you have to wait until that vendor provides everything, and then you can possibly connect or create a big 5G network. But this is different in 5G. So let's go individually to each of them. Like, so as you see here, like these are individual components in a 5G core network. Like this, let's say some mobile operator, where there is a signaling firewall through which it connects to neighboring networks. But as you see here, there is another industrial interface function, because these are individual functions and they could run in individual VMs, and then, or you can also run them in Dockers or whatever. So which was completely not possible in 4G or even before. But now additionally there's an interface which is called, let's say, industrial interface, or you could call it network exposure function. Basically it exposes the capabilities or the functionalities of a core network to outside world. So you could, so this outside world could be a small business, like any company, or it could be someone who is providing gaming, or who is providing tracking services, or who is providing automotive services. Like, you name the company, so they can actually access this particular interface. So it's kind of having a line of sight into the, let's say, mobile core network, which was completely not possible before, like in a normal open way, because previously attacks were basically over SS7 interface, where attackers used to exploit the flaws and then try to find a backdoor and then get into the core network. But now this is a legal, like open, a standardized interface, which is available for industries or platforms to install their applications, or let's say there is a cloud platform where someone who is providing like a conference like this can actually install their applications on this particular platform and directly connect with what the industrial interface function provided by that particular operator. And then here maybe we all have our mobile devices to which this conference organizer can actually send messages to. So this is the level of, this is the level where 5G will take us, and it's making the mobility even much more available than ever before. The interesting thing here is it's all based on REST API interfaces, and I think everybody is aware of REST API interfaces and then how they operate, and the number of attacks that we actually hear about APIs in daily life. I think every day you see some kind of an API attack, and that is what we are going to witness in 5G as well if things are not properly taken care. The second one is a service-based architecture, which where there is a wide separation between control plane and data plane. And this brings in again two types of networks. You could have a public 5G network where we are having our mobile phone calls, or even let's say emergency calling, or even our data transfers can actually go over the public 5G network. And then by this separation, it also brings in something called private 5G networks. So you couldn't just go to any cloud provider, just buy the cloud, install the kind of core network that you want. I mean, you could install your own core network. You could randomly find so many open source 5G or 4G core networks, put it there. And then you can connect that particular core network to a particular, let's say, mobile operator, who is actually having a legal authority to run a base station. So this again brings another open interface where anyone can connect, or let's say anyone having a business can actually connect their own core network to mobile operators network, which is again not possible previously, but now this is opening another door, a legal door, a standardized door, which will create another attack surface in 5G. And I think, I'm not sure how many of you tried this AWS private 5G, and it's quite interesting to see what kind of features are actually available. But there are plenty of providers who provide cloud platform where you can install your own private 5G core and try to integrate that with any network provider that you want. If you are someone who is interested more on the open source side, there is also something for you on 5G where it's possible to build a complete open source network right from the scratch. Maybe if you are in the mobile world, you might have heard this term called ORAN, which is an open radio access networks. So I think one of the reasons why ORAN was also is in the news today, or why it's quite popular, because of politics as well, so that base station hardware should not be anymore some kind of a closed source entity that nobody has access to. And the speculations that come around closed source hardware and closed source software. The second factor is that to allow integration of multiple providers, so that you're not locked to one particular vendor, and you can actually mix and match different providers so that you can provide maybe a better service. For that, they actually, I think there's a standardized way, how Ubuntu is actually helping to get this Open RAN, a standardized radio access network hardware, or an operating system for them. I don't want to talk about the core network, which is from the Magma, or I also talk about the clouds as well, but at least all these things would be, or let's say the RAN or the core network would be completely virtualized, which was not possible earlier. And I'm not saying virtualization is something that is that has so many flaws in it or something, but this is completely a new platform, or a new way how mobile networks will be seen for the next, let's say, 20 years. This will bring in a new threat landscape, at least for people who are engaged in mobile networks. So if things don't properly get installed here, it's, let's say, if you talk about previous 4G mobile networks, so if something is not properly installed, maybe the one affected is the operator, the one who is using your phone, and it's these are the things. But now with this, you're actually bringing so many industries onto the same platform. So if things are not properly installed, so it's basically the industries will get affected on top, the providers, the cloud providers, and also the network providers like you name the operator. So maybe you might have come across this term called there would be like billion devices connected, like IoT devices that would be connected. So some interesting things here are like when you connect those many number of devices, or we were talking about private 5G networks and public 5G networks where you have mobile phones, you have smart devices. You take any device, like so many robots that are actually connected to this 5G network, and would the current, because like every device has a different security settings. I mean, you don't really have to worry about some device that's just doing a temperature reading compared to a device that is sitting in an embassy. So there is quite a difference in terms of providing security. So there comes the network slicing, where the entire core network could be sliced, and each of them could be catered to provide a different service. So in that case, like, what kind of things can actually go wrong? I mean, there will be like tons and tons of configurations that might actually go wrong. And something that we saw or like witnessed these days was like, because I said there will be like billions of devices, so you can actually scan from your mobile phone, you can actually scan the operator network. I mean, you can also do it on your phone, and normally you see that normal mobile phone networks, I mean, by now, there shouldn't be any kind of like open ports, or they shouldn't expose any other devices. So basically, you should not be able to reach from your mobile phone to your friend's mobile phone, assuming you're on the same operator network. This route like should not be allowed directly inside a NAT. But what we see is that when you look at IoT networks that are today, or like some recent IoT networks starting, I think, around from 2016, like by now, there are so many narrowband IoT networks that are actually available from so many providers in so many countries, because these are specifically designed for IoT networks. I mean, they don't actually work for mobile phones. So you cannot take a mobile phone and then connect it on an IoT network, because their settings are different and then everything is different. So we try to see whether we can actually intrude into one of these IoT networks that are actually available these days. Technically, yes. We tried into maybe around 6 or 7 networks, and it was possible that all of them we were actually able to penetrate and then try to reach the mobile devices, or try to reach other devices which are hosted on the same platform and don't belong to us. And this itself is a complete disaster, because hereafter, like, I mean, I think if you're doing pen testing, you know the next steps as well, like how it goes on from here. So there are like a couple of other interesting findings as well, which I'm not revealing yet because we are still in this disclosure phase. But I would like to conclude this talk with some takeaways. So definitely the RAN security, or like over-the-air interface security, is improved in 5G when you look at what actually happened in 4G. So, and the 5G security that we have now, which is anyway, like I said, based on 5G NSA mode network. So don't have the false sense of security that we are already in a 5G network, because we are really not. And even though if you have a 5G, if the protocols are not fixed and do not follow the new security mechanisms that have actually come up with 5G, so then we are again going back to the same past where so many attacks actually happened. Then for end users, I think, like I said, there is no way we can actually choose. And I don't think like none of the providers or like operators or even phone manufacturers would like to provide you the feature of 5G only. Maybe if you know how to enable that, you could do it on certain phones. But it's not going to be a feature that would be provided. Finally, like there will be like new security domains. So we won't be talking just RAN security. When we talk about cellular networks, like we also talk about virtualization, we also talk about APIs, we also talk about clouds, SDN. So it's basically not just anymore a simple mobile network where two phones can communicate, but it's just a huge mix of lots and interesting security domains all together, placed on one single box, I would say. So yeah, that's it. And then thanks for listening. Thank you. If you have some questions, I think.
I think we don't have time for many, so we'll keep this quick. I was just wondering about VPN clients that we can use to protect in 4G, and will they affect the efficiency and network with 5G?
Yeah. I think like 4G doesn't really offer the like the amount of speed or the ultra low latency. So it's only available in 5G. But if you're again using VPN, I think you're actually killing the purpose of having a high-speed network. But I mean, it depends on like where exactly. So to address that, there is also something called edge computing, like where they bring the entire intelligence to the base station itself, or like to very close, so that you can solve this kind of, let's say, the latency issues. Yeah.
Okay, very last question.
So how secure 5G with respect to 4G and 3G? I mean 5G APIs specifically.
I think if you're talking about API, it's the same kind of API that you see everywhere. So if you don't follow the standard guidelines for APIs, I think it's the same level of security. So API is API everywhere. So, and I think there is standardized recommendation to use TLS and OAuth for API usage in 5G networks. So if that is not followed, I think it's again the same.
But with respect to 3G and
if you are comparing the RAN level, yes, it's quite improved. And like I said, most of the features are optional. If you don't get them right, then you are again going back.
That's great. Thank you.